All right, guys, on exit slip 211 here, our I can statement was to be able to solve problems dealing with equivalent ratios. Okay, so we'll look at a few different problems here. We're going to write an equivalent ratio, so a ratio that's equivalent in value. And there are a lot of answers, there are infinite amount that we could have here, but we know just like with fractions, if I do something multiplicatively to one side, if I do the same thing to the other, it keeps that same rate. So for example, a simple way to do this, if I double the 4, it becomes an 8, and if I double the 5 times 2, it gets 10. So if I just do, and taking it times 2 just means I'm doing that 4 to 5 rate 2 times. So 4 to 5 and 4 to 5 becomes 8 to 10. Okay, it's the same rate, I just did it multiple times to get to 8 to 10, but it's the exact same ratio. All right, so if I took them both times 3, I'd get, another example could be 12 to 15. Again, just doing mentally this times 3 and this times 3. Again, there's infinite answers that could work for these. Okay, 3 to 4, I'm just going to double both, make it simple here. That's a 6 to 8 ratio. All right, 12 to 20. Now, when you start getting bigger, sometimes, remember, it's not only multiplicative, but I could divide as well. You find a common factor, like 12 and 20, they can both divide by 4. And if I divide by 4/4, again, it's kind of like dividing by 1, right? So I get an equivalent value. So that would change. 12 divided by 4 is 3, and 20 divided by 4 is 5. So a 3 to 5 ratio is equivalent to 12 out of 20. Or I could multiply like I did before, and I could double them both and get 24 to 40. If I double both of those, that would be another way to look at it. Usually when they're smaller, though, it's in a form that's a little bit easier to understand. So sometimes we want to get it into a little bit of a simpler form. 18 to 36, too. Now, my brain sees right off the bat that 18 is half of 36. I know this is a 1 to 2 ratio. And to get that, again, I'm just dividing both sides by 18. If you do the same to one as you do to the other. But sometimes your brain sees that connection. 18 is half of 36. So the easiest way to probably write it is a 1 to 2 ratio. You could also divide and get other ones that are smaller like that with a common factor. But I could double it also, okay? Because again, there's infinite answers. I could double each of them. So I'd get 36 70-seconds. And again, looking at something like that, 1 is half of 2. 36 is half of 72. 18 is half of 36. The first one's always half the second one. Again, so you've got that same rate. Just different ways to think about that, okay? The first problem here, solving a word problem here. Jose is mixing paint to make the correct shade of green. He must mix 1 part of yellow with 4 parts of blue. So he's got to keep that rate to get the color that he wants. So he decides that he's going to mix 3 yellows to 12 parts blue. 3 parts yellow to 12 parts blue. Will Jose's green paint be the right color? Did he keep it equivalent? Okay, so our job is to explain, would that work? And I see that what he did from yellow, he went from 1 to 3. So I can see that he tripled it, and he took the 4 to 12. So he basically tripled both of them, right? So he kept the same rate. He just 1 out 1 to 4, 1 to 4, 1 to 4. He did it 3 times. That would get me 3 to 12. So to explain, I could say, will his green be the right color? Yes. He kept the same rate. He just did it 3 times. All right, this would be, too, if you're doing recipes and you're trying to double or triple a recipe for cookies or something because you're making a big batch, you would have to keep the ingredients at that same rate to keep it tasting the same. Same thing here. If you need more paint, you need to mix it at the same rate so you get more that looks the same. Okay, and this is something, there's a lot of times when you'll need to do that. In the second one here, Lucille is making flower arrangements, and for every 2 roses, there are 6 carnations. Okay, so I'm going to go over here off to the side and do my quick ratio. It's a 2 to 6 ratio, and I'm going to label up above of roses to carnations. We know roses come first. We have to do it in the right order. So for every 2 roses, there are 6 carnations. And she's going to make an arrangement with 5 roses and 15. She wants to get it to 5 to 15. Sorry, turn this back on here. Okay, so we want to know if 5 to 15, is that the correct arrangement? Did she keep that same rate? So some people, when you're looking, you're going from a 2 to 6, and you're trying to get to a 5 to 15, and some will say, well, maybe I don't think that gets along, because 2 times what gets me to 5? What are you multiplying by? It just doesn't look right. So you have a couple of options here, okay? I think the simplest option maybe is to change forms. Can you get this to a simpler form? I see 2 and 6. If I divide them both in half, or cut them in half, this is the same as a 1 to 3 ratio. For every 1 rose, you need 3 carnations. Okay, that's kind of a unit rate. We've got it in its simplest form there because there's a 1. Well, when I look at it this way now, if it's 1 to 3, can I get that to a 5? And I can by taking it and doing this rate 5 times. So I have to do the rate for carnations 5 times. And it does end up 5 for 15. Okay, so the rate is the same. Sometimes you have to change forms to get the numbers to match up. All right, so down here when we can explain, we could change 2 to 6 to 1 to 3 ratio, which then changes to 5 to 15 rate. Okay, so one of your options there is to see if I can change forms where the numbers get along a little bit better, and you can find if it's equivalent a little bit easier that way sometimes. Okay, so yeah, and I'd make sure you'd write down this stuff. I'm going to look at one more little complex way here. Okay, so again, I'll pause this if you need to here. Okay, but I'm going to start here and say, can I get to 5 to 15? And guys, if I divide 5 divided by 2, it's going to tell me how much bigger this is. 5 divided by 2 is 2.5. And 15, if I divide that by 6, you're going to get also 2.5, which is telling me that each of these bottom numbers are 2.5 times bigger than the top number. So actually, if I took 2 times 2.5, it gets to 5. If I did this rate 2.5 times, and if I also did 6 2.5 times 2.5, it does get to 15. So a little more complex way to think about it. You could multiply by fractional or decimals sizes, and if you multiply 1 and do it 2.5 times, and do this 2.5 times, it does get to this. Now, but you can't do 2 out of 6 2.5 times. That gets a little bit more complex. That's why we like to change that form, do a simpler form that gets along. But technically, this does work and show you that it's at the same rate. I just multiplied them both and did 2.5 times more for both, so it keeps that same rate.